Hello, in this video, we will use a simple example to demonstrate how to write recursive function. Recursion is at the function level. Recursive programming is to write recursive functions. A function is recursive if the function invokes itself directly or indirectly. So we're going to use this classic example to demonstrate recursion. This is called computing factorial. This is not a good candidate for writing recursive program, but it's a very simple way to demonstrate how recursion works. So we are familiar with this factorial. The definition of factorial is the factorial of 0 is 1, and the factorial of n for n is greater than 0 is n times n minus 1's factorial. So this is recursive definition. It leads to a recursive function very naturally. So what we have is this is the recursive function. We're going to write factorial n. If n is 0, return 1, else return n times factorial n minus 1. Let's write the program here. It is the factorial n, very simple, straightforward implementation. If n is 0, return 1, else return n times factorial n minus 1. So let's see how it works through the animation.
The program loads the definition for the main function to the memory. The program loads the definition for the factorial function to the memory. The program invokes the main function. The main function is invoked and pushed to the stack.
When a function is called, an activation frame is created and pushed to the stack. In this activation frame, it will store the parameters and local variables in the activation frame. So now we have this pushed to the stack, and next you can see this n.
The statement displays a message to prompt the user for input.
So let's put n is 3 here. So now you see
prompts the user for an input. Read an input 3 from the console and assign it to variable n.
So the reference variable is declared here. It points to the object. And so this object, it's actually it's somewhere in the heap, but let's, for simplicity, we just put the number right here to know this is declared. This is n is a number. So we assign this number to n. Now we are going to invoke factorial.
The program invokes factorial
3.
n.
And n is 3.
Factorial 3 is invoked and pushed to the stack. The value of n in the main function is passed to factorial.
Calling factorial 3.
The statement tests if n is equal to 0. It is false since n is 3. The program invokes factorial 3 minus 1.
Invokes factorial 2.
Factorial 2 is invoked and pushed to the stack. The statement tests if n is equal to 0. It is false since n is 2. The program invokes factorial 2 minus 1.
Invokes factorial 1.
Factorial 1 is invoked and pushed to the stack. The statement tests if n is equal to 0. It is false since n is 1. The program invokes factorial 1 minus 1.
Invokes factorial 0.
Factorial 0 is invoked and pushed to the stack. The statement tests if n is equal to 0. It is true since n is 0.
N is now 0. This is true. Return 1. So the return is now the function is finished. Exit. Return it to its caller. The caller is factorial 1. So every time you invoke a function, you put the information for the function on top of the stack in an active version frame. When you finish it, the active version frame is popped out.
The statement returns 1. Factorial 0 returns 1 and it is removed from the stack. Factorial 1 is on the top of the stack. The statement returns 1 times 1 from factorial 1. Factorial 1 returns 1 and it is removed from the stack. Factorial 2 is on the top of the stack. The statement returns 2 times 1 from factorial 2. Factorial 2 returns 2 and it is removed from the stack. Factorial 3 is on the top of the stack. The statement returns 3 times 2 from factorial 3. Factorial 3 returns 6 and it is removed from the stack. The main function is on the top of the stack. The statement displays the result.
Now, after this statement is finished, the main function is finished. Stack will be empty.
The main function is finished and removed from the stack.
So you see how a recursive function is called on the stack. So it builds up every time a function is invoked. So stack size is increased. So how do you trace the function call is on top of the stack? It's always once a function is finished, so it's removed and then come to the next, that's the caller of the previous function. So let's look at this animation again, and this is the one in the call stack with factorial 4. So this is the activation record for factorial 4 is now pushed to the stack. So now invoke factorial 3, factorial 2, factorial 1, factorial 0, and now 0 return 1. And this factorial 1 is returned, factorial 2 is returned, factorial 3 is returned, factorial 4 is here returned. This is how this works. Now, please note that when you write this code here, this is the best condition. You must have it. Otherwise, you are calling this function infinitely. So this is infinite recursion. You always have the best condition to start the recursion. And this is a reduction. So the problem was factorial n. Now it's reduced to factorial n minus 1. That is all for this simple introduction using this computing factorial problem. We will use another problem to demonstrate recursion in the next video. See you on the next video.